So we're going to try and do our second part, right? So I'm going to be posting the pictures on my TikTok. You can follow me on TikTok or Facebook. We'll also post them on Facebook so that you may be able to actually get the picture version or the PDF. If you want the PDF, you can actually email me and I'm gonna send it to you. Okay, so resistance and equivalence, resistance and equivalent resistance, right? Okay, so this is what we have. The question says calculate the equivalent resistance of series and parallel arrangements of resistors, right? So for series circuits, number one, when we have series circuits, this is how we are going to have our circuits looking. R total is equals to R1 plus R2 plus R3 plus R4 plus 1, 2, 3, going forward, right? So the total resistance will always be larger than the largest value here for the series circuits. So you might have our battery. So this is our battery here, and then this can be our resistor number one, number two, right? So this is our resistor one, resistor two. Let's say for example resistor one is 30 ohms and resistor 2 is 6 ohms. So resistor 1 plus resistor 2 is equals to R total. So it's 3 plus 6, which is equals to 9. Do you understand? So effects of adding more resistors in series, the total resistance increases. Number one. Number two, total voltage will increase. Number three, total current will also increases. And then the parallel circuits. When we have parallel circuits, for parallel circuits, the connections will be different, right? For parallel circuits, 1 over R total is equals to 1 over R1 plus 1 over R2 plus 1 over R3 going forward. So the benefits of adding the resistors in parallel. In parallel, number one, the total resistance decreases, right? Number two, the total voltage will be the same. Number three, total current increases, right? Okay, so how are the cells aligned? How are the resistors aligned? So this will be your battery. So this will be your battery there, number one. Number two, this will be our resistor, and this will be our resistor. So R total 1 over R total is equals to 1 over R1 plus 1 over R2, like that. So that's how the circuits will be arranged in parallel circuits. So that's how they will be arranged, right? Right. Okay, let's have a question or a scenario that we can look at. Right, so this is what we have, and I'm just going to give you a question, and I want you to try it and see if you can work it out. So this is my battery, right? And then this is resistor 1. So this is resistor 1, and this is resistor 2, right? And this is resistor 3, and this is resistor 4, and this is resistor 5, and this is resistor 6, right? And then yes, that's my circuit, complete circuit like that. So calculate the total resistance of the circuit that we are given there. So let's say our R1 is equals to 3, right? So this is 3 and this is 4. 3 ohms, 4 ohms, 6 ohms, 7 ohms. We also have 10 ohms and 1 ohm. So we can label. The first thing that we can do is to actually identify and label. This is our A connection, our B, and our C. So you first calculate the total for this part, which is the A, for this part, which is the B, and for this part, which is our C, right? So now that we are going to calculate the total, so the total, as you can identify here, the series are in circuit. The circuit is in series, right? So RA total is equals to 3 plus 4, which gives us what? 7 ohms, right? And then RB total is equals to 6 plus 7, which gives us what? 13 ohms. RC total is equals to 10 plus 1, which gives us 11 ohms, right? Now that we have our 11 ohms, so we can actually write it as this. So we have 7, right? And then for this part, we're going to erase it, and it's now going to be 13 ohms, right? And then this part, we are going to erase it, and it's now going to be 11 ohms, right? So now that, can we see that it's like this? Can we see that our circuits are now in parallel? So 1 over R total is equals to 1 over RA plus 1 over RB plus 1 over RC. So 1 over R total is equals to 1 over 7 plus 1 over 13 plus 1 over 11, right? So now that we have that, you can now get the inverse of what we have. Get the inverse of what we have. So 1 over R total is equals to that 1 over 3,22. And then you get the inverse of this, the inverse of this. So R total is equals to 3,22 ohms. That's how we get our answer there. So it's as simple as that, right? So the internal resistance, the EMF, and those are some of the things that you need to know. So the internal resistance is the opposition to the flow with the cell or battery due to its chemical composition, right? So EMF is the total energy supplied per coulomb of charge that passes through the cell, right? So how do we get EMF? EMF is equals to V load plus V internal resistance, right? So what is V load? This is the voltage of the load, or or whatever that will be connected to the circuit. And then V internal resistance, this is the voltage of the internal resistance. Right, so let me draw it for you. I'm not good at drawing, so you can just see it like this. So this is R, and this is our voltmeter, and then this is our battery, and this is our small resistance here, and this is our line like that. So this is our V load, right? It's connected like that, and then our V is and our resistance. So this is our battery, and this is our, and then our E is somewhere here. So right, so V is always equals to E minus I R, like that, like that. When our graph is in the form of y is equals to mx plus c. So a graph that is in the form of y is equals to mx plus c, this is a straight line graph. This is a straight line graph, and it's easy to use. So the slope, as you can see on this part, it's actually negative, right? So since it's negative, it's going to have a negative gradient, right? And how do we get the gradient? Gradient is equals to change in voltage over change in current. There, that's how you have it. So this will be your voltage and this will be your current, right? Okay, and then how do we get power? Power is equals to the work done over the time taken, right? So work done over time taken, this can be represented by the formula, which is equal to the formula P is equals to VIT over the time. So it automatically gives us P is equals to VI. But this is in your formula sheet, so there is no need to really cram it or need to know it. And then voltage is the same as IR, right? So instead of writing it as like this, you can now write IR times the current. So power is the same as I squared R, like that, right? Like that. So that's how you can get our answer there, right? Like that. So that's how we can get our answer there. So I will see you in my next video. I'm gonna see you in my next video there.